Let's start by looking under the hood of the human brain, because when we talk about focus, we're not just talking about a mindset or an idea. We're talking about a very real, very physical mechanism that can be located, measured, and, most importantly, trained. At the center of this mechanism lies a region of the brain called the prefrontal cortex. This is the area right behind your forehead, and it's responsible for what we call executive function: planning, decision making, suppressing impulses, and yes, focusing. But the prefrontal cortex doesn't operate in isolation. It relies heavily on signals from other areas of the brain, especially from a small but powerful region in the brainstem known as the locus coeruleus. This region is the brain's main source of norepinephrine, a neuromodulator that acts like a chemical signal booster. When norepinephrine is released in appropriate levels, it heightens alertness and selectively amplifies neural activity in specific circuits. In this case, the ones responsible for directing attention. This is where the concept of the focus switch comes into play. Think of the locus coeruleus as a volume knob. When it's too low, your attention drifts, your thoughts are cloudy, and you feel tired or sluggish. When it's too high, your thoughts race, you're jittery, and it's hard to hold on to a single idea. But when the volume is just right, moderate, sustained norepinephrine release, you hit the sweet spot of calm, alert focus. That's the neurological state where deep work happens. Now, there's a second chemical player that's equally important here: acetylcholine. This neuromodulator works more like a spotlight. While norepinephrine enhances overall alertness, acetylcholine helps to narrow your attention. It sharpens the signal to noise ratio in your brain, making certain neurons more responsive while dampening irrelevant inputs. When acetylcholine levels are high in the prefrontal cortex and sensory pathways, your brain effectively says, "This is the thing we're doing." Everything else can wait. Understanding this dual system, norepinephrine as the volume knob and acetylcholine as the spotlight, gives us the biological framework for what we're calling the focus switch. When both systems are engaged at the right levels, you experience a state of directed attention. You're not just awake, you're aligned. You're not just alert, you're absorbing, processing, and producing at a high level. This system didn't evolve for spreadsheets or writing code. It evolved for survival. Think about our ancestors tracking prey across vast terrain, scanning for slight movements, subtle patterns in the environment. Their survival depended on the ability to lock attention onto one target for hours at a time while filtering out distractions like wind, heat, or noise. The focus switch is primal and incredibly powerful. It's still in you and it's accessible. But in our world, it's constantly being overridden by technology, overstimulation, and fragmented attention. Every notification, every swipe, every email trains your brain away from sustained focus and toward novelty seeking. What's fascinating is that these neuromodulators Norepinephrine and acetylcholine are not fixed. They can be influenced by behavior, by environment, and even by thought. For example, studies show that mental effort alone can trigger activity in the locus coeruleus. Simply deciding to pay attention increases norepinephrine release. That's important because it means intention matters, but the effect is weak unless paired with the right behavioral and physiological tools, which we'll talk about shortly. Another key detail here is these neuromodulators don't act instantaneously. There's a ramping process. When you engage in an attention-demanding task, norepinephrine rises quickly, but temporarily. If you push through the first minute or two, the system stabilizes and the brain enters a more locked-in state. This is why the first few minutes of work always feel like resistance. It's not a psychological block, it's a neurological threshold. Also crucial to understand dopamine. The motivation molecule plays a supporting role. It doesn't directly create focus, but it strengthens the networks that do. When you receive even a small reward, completing a task, checking off a box, dopamine reinforces the circuit that just executed that behavior. That's why systems like Pomodoro timers or micro goals are effective. They work with your neuromodulatory system, not against it. And this leads us to the most powerful realization. Focus isn't something you wait to feel. It's something you can initiate, like flipping a neurological switch. You need to create the right chemical conditions in your brains. That begins by understanding the levers norepinephrine for general arousal, acetylcholine for precision, dopamine for reinforcement. So when you sit down to focus, know this, your brain is not working against you. It's wired to focus, but it needs a signal. That signal isn't magical and it isn't emotional. It's physiological, it's biochemical, and it's entirely under your control once you know how to trigger the systems. Now that we understand how the brain generates focus through norepinephrine and acetylcholine, the next question is this: how do we activate these systems when we need to? How do we take control of the switch and deliberately flip it, even when we don't feel like it? The answer lies in specific science-backed protocols, actions that send clear signals to your nervous system that it's time to engage, to narrow the field, and to lock in. One of the fastest ways to initiate the focus state is through the eyes. Why? Because your visual system is the most direct path into the brain's attentional networks. What you look at and how you look at it immediately affects your state of arousal. This isn't metaphorical. Your eyes are part of your central nervous system. They're essentially two pieces of brain tissue that have been pushed out into the world, scanning and sending data back into your skull. Here's what that means practically when you direct your gaze to a single point in space, what we call visual anchoring. You engage a mechanism called the reticular activating system, which signals your brain that it's time to pay attention. When you narrow your gaze, you narrow your mind. and it works in reverse tubes. When your eyes are darting around, shifting, scanning, your brain stays in exploration mode.